So hi guys, we are going to discuss Laplace transformation, and this video series is especially designed for GATE exam, right? And we are going to deal topic wise, and after every topic we are going to finish related question whatever they have asked in GATE exam, right? And then in the last I will discuss some tricks. So this is our first video, so I have written part 1. Let's go to the topic now. So by using Laplace transformation, we convert any function of time domain into frequency domain. Okay, so if you have a function given in time domain, by using Laplace transformation we can convert into frequency domain. Here we have a small f and here we have capital F. S is the symbol for frequency domain variables and T is the symbol for time domain variables. And very important thing is Laplace transformation helps in solving differential equation with boundary conditions without finding general solution, right? So like you will be knowing like there are Bernoulli equation and other equations in differential form. So we can solve them without going through differential concepts. By using Laplace transformation only we can solve them, okay, very easily. And actually it's very helpful also for GATE exam. So let's start here. So Laplace transformation is done by using this formula. So formula is, if a function is given ft and we are going to use Laplace transformation, here capital L is the symbol for Laplace transformation of this function. So formula is 0 to infinite e power minus st ft dt. Dt is, we are integrating our function which is already in time domain, and here we are using s, means our answer, and here this s will be a constant, means our answer will come in form of s, like s will be there in the answer. So that will be answer in frequency domain, right? That will be a new function which will be having variable s. So capital F is the function. So keep in mind this integration must exist, then only we can integrate and come till the answer, right? Okay, as we know that we have several types of functions, right? Like trigonometry, exponential, algebraic, logarithm, blah blah blah, and so on. So by using the previous formula, first of all we'll see their Laplace conversations, like we are going to see convert only sine, only log and blah blah things, and then we'll go for their operations. So see one example, Laplace transformation of any constant number. For example, take 1 as the constant number, and we are using capital L for the symbol of Laplace transformation. So answer will come 1 by s. How? By using this formula. Okay, so let's see how it is coming, but here I will show only this function, and then remaining we have to mug up that answers. Okay, so ft is 1 now, so substitute 1 here, then multiply and then integrate for t, integrate this function, you will be getting this, and then substitute limits minus infinite and 0, and then e power minus infinite will come as 1 by e power infinite, and this will be 1 by e power 0. And lot of students are confused here. For example, suppose if I tell you 2 power infinite, then answer is infinite. If I say you 0.2 for infinite, then answer is 0. So keep in mind. And because I mean to say, if your given number is greater than 1 and then power infinite, then answer is infinite. But if the given number is between 0 and 1, I mean decimal numbers, then power infinite is 0. Keep in mind. So, and e value is 2.7, right? E value, what we are using here, this value is 2.7, right? So this is more than 1. So e power infinite means 2 power 7 power infinite. That's why answer is infinite. So 1 by e power infinite, this will be infinite. So 1 by infinite will be 0. I have taken here like this. So 1 by infinite is 0. 1 by 1 is 1. And that's why this minus 1 multiply with this will be getting 1 by s. So that's why Laplace transformation of 1 by s, right? As you can see, this process is really very lengthy. So for GATE exam we are not going to apply this formula again and again. So we are going to mug up lot of important results. So we are going to remember all standard answers of basic functions. Then we have to use operations involved in Laplace transformation. So our first and very popular is t power n, right? Like in differentiation we have x power n. When we differentiate x power n, we get n x power n minus 1. In integration also, like x power n, if you want to integrate, then it will be x power n plus 1 by n plus 1. So in Laplace transformation also we have t power n. That answer comes as factorial n divided by s power n plus 1. From where this s is coming, this is only that frequency domain, right? Okay, so your answer, whenever you will convert Laplace transformation of time domain, your answer will come already automatically in terms of s, right? Okay, and keep in mind, this factorial n is nothing but gamma function of n plus 1. This symbol what I am drawing here, this is gamma function, okay? And again, if you can convert as n gamma n, right? And don't be confused with gamma and root. Root is different, gamma is different. And also keep in mind, gamma of 1 by 2 is under root pi. Here this is gamma and this is under root, okay? So let's see one example, Laplace transformation of t power 5. So here n is 5, so factorial n s power n plus 1, correct? So if you'll open factorial 5, your answer will be coming something whatever, about 120, and this will be s power 6, right, when you will add 5 plus 1. I hope it's clear. Let's see one more example. Here in this example we are going to use Laplace transformation of t square under root t. L is the symbol for Laplace transformation and our function is t square under root t. Tt is given, it means it is already in time domain, and we have to convert into frequency domain. It means our answer will come in terms of s. So again, t square root t you can write as t square t power 1 by 2, which is going to be t power 5 by 2. So one way is to use the given formula what we know already, right? But this is very lengthy way, so we are going to use this formula, okay? This formula we are going to use. So Laplace transformation of this you can convert like this, t power 5 by 2. So n value is 5 by 2 now. So formula is factorial n, so 5 by 2 factorial, and s power n plus 1, it means s power 5 by 2 plus 1, and factorial 5 by 2. How to solve? When you will solve factorial 5 by 2, your answer will be 15 by 8 root pi. Let's see how. And this part will be 7 by 2 s power. Let's see how. So this you can write as this is gamma function now, and just now we saw here gamma function we can also write, yeah, here you see gamma of n plus 1 is n gamma n. That's why gamma of 5 plus 2 plus 1 is n gamma n, right? So this again, this 5 by 2 you can write as 3 by 2 plus 1. Then again n plus 1 you will apply here, then n gamma n. Then again this 3 by 2 you can write as 1 by 2 plus n. So again gamma n plus 1 will be n gamma n, right? And in the last we are remaining with 1 by 2. So gamma 1 by 2 is root pi. So this is how we are getting 15 by 8 root pi, okay? Keep in mind, this is under root pi, okay? It is not gamma pi. This one is gamma, but this one is root, okay? So we got one more question here for better understanding. So we have Laplace transformation of t power n minus 1 and divided by n minus 1 factorial, okay? So as you know, this part is n, right? So it will be just a constant number. So we don't have to do anything with this. So this will be as it is in the answer, no problem. So we are remaining with t power n plus 1. That is the final thing. So again, we are going to use this formula. So now this total is our n. So factorial n we are writing here, correct, right? And s power n plus 1. So our n is n minus 1. So this will get cancelled. I mean minus 1 plus 1 will get cancelled. So we are remaining with s power n, and this part will get cancelled by this part. This is coming because of formula of this, and this is already given in the question. So we got 1 by s power, right? So now we will see the list, formula list. If they have given e power at, so directly 1 by s minus a. How this is coming? This is coming by using that big formula, okay? I mean this is coming by using this formula, okay? So we are not going to prove here, because in GATE exam we are not bothering about proof. You probably have done in university exams, fine. So and Laplace transformation of sine at, okay? This can be any constant number, 1 2 3 4, anything. So this a you keep here, a square you keep here, and s will come, right? S square. So a by s square plus a square. If you have cos at, then s by s square plus a square. If sine, then a. If cos, then s. You can make this trick. Cos is being end at s, so that's why s by a square. So other one is automatically a by. Fine. Now, if it is given hyperbolic function, then use negative sign here and here. Okay, I mean to say Laplace transformation of sine hyperbolic at. So, and cos hyperbolic at. So because cos ends s, so cos is ending at s, so that's why s by s square minus a square. And other one is a by s square minus a square. I hope it's clear. In GATE 2003, in civil engineering, for 2 marks, they directly asked the formula itself. Laplace transformation of sine at is a by s square plus a square. This was the option, right? And one more thing, same year in mechanical engineering, they asked same problem. They only changed this a with omega. See here, sine omega t. So answer is omega by s square plus omega square, right? So this is our very basic part 1. We are going to discuss part 2 in the next video, but I'll give you one homework. This is very, very important. Okay. Laplace transformation of sine hyperbolic t. Okay. This h is for hyperbolic function. Again, plus cos hyperbolic t. So convert this, comment your answer in comment box very quickly. Then homework, next homework, Laplace transformation of e power x minus e power minus x by 2. So these 2 questions we are going to discuss as homework. So in next video I will explain this, and in my video I will say whoever has done. I will take the screenshot and I will say who has replied. Thank you so much, and go for the next video.